Hey everybody, Mr. Murphy here with another video lesson. This time we're going to go over area of composite figures. And just to remind you what that is, composite figures are any shape like this one that is made up of smaller, more basic shapes. So up here I'm just going to write made up of basic shapes. So when I say basic shapes, I'm referring to shapes where we know an area formula for them, such as squares, rectangles, triangles, circles, that sort of thing. Anything we already have an area formula for, you could think of as a basic shape. Okay, so for example number one, we're going to find the area of the entire composite figure, and you'll notice the area has already sort of been divided into 1, 2, 3 rectangles. So we are going to add the 3 rectangle areas to give us our total area. Now, of course, for the area of any rectangle, we know area of a rectangle is equal to base times height. In other words, length times width, however you want to look at that. Okay, cool. So let's begin with rectangle A. We have the 2 measurements for it here. The base is equal to 4 meters. The height is equal to 6 meters. So the area would be equal to 4 times 6, which would be equal to 24 meters squared. Okay, piece of cake. Area equals 24 meters squared. Now, for rectangle B, we have the length of the base, 3.5 meters, but we do not have the length of the height. However, we know that this height of rectangle C has a length of 3.8 meters, and then this part is worth 2 meters out of that 3.8 meters. So we're going to do this. 3.8 minus 2.0. That's going to tell us the height of rectangle B. 8 minus 0 is 8. 3 minus 2 is 1. So this is a height of 1.8 meters. Okay, so now it's just a matter of doing area equals base times height. 3.5 times 1.8. Let me go ahead and calculate that real fast. That is going to be 3.5 times 1.8. That should give you exactly 6.3 meters squared for rectangle B. Now, last but not least, for the area of rectangle C, we need, again, base times height. So that's going to be a base of 3, height of 3.8. Multiply those together to get your area. So that's 3 times 3.8. That should give you exactly 11.4 meters squared for the area of rectangle C. Okay, that's cool. So now, to finish finding the total area, remember we're just going to add the 3 rectangle areas together. So I have 11.4 meters squared plus 6.3 meters squared plus 24.0 meters squared, or just 24. Add that all together. 4 plus 3 gives me 7. Bring down the decimal. 1 plus 6 is 7. Plus 4 is 11. Carry the 1. 1 plus 1 is 2. Plus 2 more. Your total area should be 41.7 meters squared. Okay. Cool. So with composite figures, one good strategy is to split your shape up into smaller basic shapes that you know area formulas for, and then add those small shapes together. Okay, example 2, another good strategy for finding composite area, sometimes you have to use this strategy, is to, for example, you see how we have a circle with a trapezoid inside? If you look, only the circle is shaded, the trapezoid is unshaded. So if I want to find just the shaded area, what we're going to have to do is area of circle minus area of the trapezoid. because the trapezoid is inside the circle, we can just subtract its area to find the shaded amount. Cool. So let's start with the area of the circle. Area of the circle we know is equal to pi r squared. And then we know the formula for area of a trapezoid is equal to 1/2 base 1 plus base 2 times the height. So circle area minus trapezoid area. Let's go ahead and find these two values separately. So for the circle, I see that this length, the diameter, is 20 centimeters. That means the radius is going to be half of that, so 10 centimeters. So it's going to be pi times 10 squared. If I do that, that'll be 100 pi minus 1/2 of base 1, let's call it 12, plus base 2 would be the 20. And then the height of the trapezoid is perpendicular to the bases, so that 8 centimeters would be your height. If I go through and substitute that in, that's going to be minus 1/2 of, what you call it, that'll be 32 times 8. And if I want to, I can take half of 32 to get 16 times 8. So that half is used up now. 100 pi minus whatever 16 times 8 is, which I can multiply real fast and tell you. That's going to be 128 units. In this case, centimeters squared. Okay. Now, we'd like a more exact value for pi, so we can actually subtract it by 128. So in this case, let's go ahead and substitute 3.14 as the value of pi. So if I do that, 100 times 3.14 minus 128, that becomes 314 minus 128, which gives you, let me subtract that real fast, minus 128. That should give you about, because we rounded, about 186 centimeters squared for your final answer. Okay, cool. Alright, so hopefully this was a helpful refresher on how to do strange areas like where you have a piece cut out or where you have shapes jammed together. But the main idea is that in certain situations, it's good to divide your area up into smaller shapes and add the areas together. But then there are also times where there are quote-unquote holes and you're just trying to find the shaded area or something like that, which is where you would want to subtract areas rather than add them together. But the two main ideas there, for composite figures, areas can either be added together or areas can be subtracted from larger areas. Cool. Hope this helps. See you guys in the next video.